Hello students, today we are going to, as because we have already started with wave optics. And in wave optics, first what we had done with the Huygens principle, and we had seen how we can prove the law of refraction as well as law of reflection with this theory. Now next we are going to start with today is interference. So today's classes are based on interference. Now, if you get to see the word interference, what does it mean? It simply means that if we have got a number of waves, let us assume there is a number of, let us assume this is one of the wave traveling into the medium. Okay. And we have got another waves traveling into the medium, and let us assume this is traveling at this direction, as this is of displacement y1. Another wave is of displacement y2. So this is y2. So what you find that due to the superposition phenomena, which phenomena? Superposition phenomena. What you really find? Superposition phenomena, we get the resultant wave as equals to y1 plus y2. That is, it is actually the algebraic sum of the displacement of the two waves. Okay. Now, here what you really find that when the waves are propagating into the same medium, then what you really find that there is an rearrangement of energy taking place, and this arrangement of energy, whatever the redistribution of energy that takes place into the media, due to the superposition of two coherent waves. I said the word coherent, two coherent sources. Now this phenomena is interference. I would like to repeat my words again. Interference is the phenomena in which the redistribution of energy takes place for the two, and it is mainly due to the superposition phenomena, due to the interfering waves into the same medium, and the waves coming should be from the coherent sources. Now what exactly is the coherent sources? We need to understand what is the coherent sources. Now suppose if we have taken two waves, okay, so we have taken two waves, and we have the condition as such that if there exists a phase difference between them, if there is existing a phase difference between the two waves, okay, then this should be phase difference should be constant, with time. It should be constant with time. If the phase difference is constant, we call this as the coherent sources. If we don't have this conditions applied over here, then we call the sources to be incoherent. Okay, so the main criteria for the coherent sources is what? That the phase difference between the two waves, let us assume this is one of the wave, another wave is not starting here but it is starting somewhere from here. So there exists a phase difference between the two. It is not starting, one wave is starting like this and another wave is starting from this particular position. So there is a phase difference between the two waves, and this phase difference, let us assume if it is 30 degree, then it should be constant with time. It should not change. That after 1 second or 2 second or 3 second, the angle, the phase difference, what I have told, 30 degree, for example, and it's not 30 degree all the time, for example 30 degree, it should be same throughout. That is what is meant by the coherent sources. Okay, that is the basic definition of a coherent sources. Now there are two methods. The methods to produce coherent source. What is the first method? The first method is the division of wavefront. Division of wavefronts. It simply means that we have seen what is exactly the wavefront. So suppose if we take the wavefront, then we can divide it into two parts so that it becomes the condition of the coherent sources. This division of wavefronts we will be applying in the, when you will do with Young's double slit experiment, that is YDSE experiment, Young's double slit experiment. When you will do this experiment, and you will have the division of the wavefront. I'll show you how it is being done in the next class. As well as Fresnel biprism also, we have the division of wavefront. So when the wavefront is divided, we are getting the coherent sources. Next is division of amplitude. Division of amplitude. So let us assume there is one waves coming out. What we can do, we can, this method, the amplitude of a wave can be divided into two parts by successive. How we can do it? You can do it by successive reflections. So this can be done with the help of successive reflections. This can be achieved with the help of successive reflection. Okay. So what exactly you have got? You have got two waves. These are the coherent sources. So if we have got this condition, then we have got the interference phenomena. And during the interference phenomena, there are two conditions. There are two types of interference. There are two types of interference. One is constructive. The second one is destructive. Now what happens in the constructive? If you have got one of the wave, this is one of the wave moving like this. If the crest of the one, and if we have another wave coming out like this, okay? So if the crest of one meets with the crest of the other and the trough one meets with the trough of the other, we get the constructive interference, okay? But what happens if one of the wave is traveling like this? Oh, sorry, we can extend it like this, and the other wave is coming out in this direction. Just ignore this line, okay? So this is one, this is displacement y1 and this is displacement y2. By superposition we will have y1 is minus y2 because it is the algebraic sum what we take. Now in this case what you really find that if the amplitude of this one is more and if the amplitude of this is less, so you get a resultant wave like this. The amplitude of the resultant wave is somewhat very less, so get the waves like, because it is the difference of the two. Okay, so we have got two types of interference. We have got the constructive interference and the destructive interference. Okay, now next what we are going to do, we need to find out the condition when it will be constructive interference and when it will be destructive interference. In order to find out the condition for the constructive interference or destructive interference, I am not deriving it. So we have got the intensity I as equals to a1 square plus a2 square plus twice of a1 a2 cos phi. Now let me just explain this. We have taken two waves. Let us assume one of the wave amplitude is a1, another wave amplitude is a2, and phi is the phase difference between the two waves. Now this cos phi becomes one of the factor which will decide whether it is constructive interference or destructive interference. In constructive interference, the value of cos phi is equals to what we get, plus 1. So what we get, I is equals to a1 square plus a2 square plus twice of a1 a2, or we can, as because we have got the intensity proportional to amplitude square, we have the intensity proportional to amplitude square, we can very well write I is equals to I1 plus I2 plus twice of I1 I2, okay, or root over, because it is a1 and a2, it is root over. So we can very well write this is root over I1 plus root over I2 ka whole square. If you just expand, you are getting back the same equation. So this is what we have got the condition, okay, that is in relative to that. Now the question arises, when is the when cos phi is equals to plus 1. So cos phi is equals to plus 1 when phi is equals to 0 degree. We have got a 2 pi, we have got 4 pi dot dot, that means phi is equals to 2m pi. We get phi is equals to 2m pi. What m is standing for? M is 0, 1, 2, 3 dot dot. We get the value. Okay, so that is the value of phi we are getting up. Okay, now we have got the relation, the general relation for the constructive interference as phi is equals to 2m pi. We have got this relation, right? Now there is another factor what we call the path difference. Now what exactly is path difference? Let us assume you have taken this as one of the waves, okay? Now we all know that here the well defined, till here and till here generally we take the wavelength to be lambda. So not necessary. If we take this position, it can be lambda by 2, it can be lambda by 4. Let us assume the particle is at this position or maybe this position. Let us assume this is the value of x. We have taken this x as the path difference. We cannot have this x in terms of lambda. Okay, we cannot find out because it's very difficult. It is not lambda by 2 either or lambda by 4. Then how we can find out the path difference or the phase difference, relation between phase difference and path difference. Okay, so we need to find out this. Now in order to get it, we will say for lambda the angle is 2 pi. For 1 it is 2 pi by lambda. So what will happen for x? It is lambda is equals to 2 pi by lambda x. Okay, so we get phi as equals to 2 pi by lambda into x. Okay, so this is phi is the phase difference and this is the path difference, so this is the relation between the two. Just now we have got for the constructive interference phi is equals to 2m pi. So let us substitute. So this is 2 pi by lambda into x. So 2 pi times 2 pi gone. So x is equals to m lambda. Okay, so when the path difference is equals to 0, when the path difference is equals to lambda, when it is 2 lambda, so there we are getting this the value of constructive interference. So we have got one relation in terms of path difference and another relation in terms of phase difference. Okay, this is for the constructive. Now let us do for the destructive interference. Now for the destructive interference, what condition we have got? For the destructive interference, we have the condition that when cos phi value becomes minus 1, or when it is minus 1, 0 is and 2 pi is constructive. So when the phi is equals to pi, 3 pi, 5 pi, dot dot dot, where m's, so we have got this condition, or we can write phi is equals to 2m minus 1 into pi. If you substitute m is equals to 1, 2, 3 dot dot. If you substitute m is equals to 1, then 2 minus 1 becomes 1, that is pi. If it is 2, 2 to the 4 minus 1, 3 pi. So that way we are getting. Again we will switch on to the same value relation between the two. So 2 pi by lambda into x equals to 2m minus 1 pi. Okay, so pi is cancelled out, so we get the condition for if we substitute, we are getting x as equals to 2m minus 1 by 2 into lambda, or we can very well write x is equals to m minus half lambda. So this is the condition for the path difference. Okay, I hope you must have understood this class. For the interference, you must have very well understood, and next class we are going to apply this interference formula for the very important part, that is Young's double slit experiment. Thank you for watching.